Hi, so one of my students came up to me and gave me a question about half-life. I didn't quite get a chance to go over this problem with him, so his name is Leon, by the way. This is for you, Leon. I'm going to answer both questions for him, and good luck on your test. I believe it's tomorrow. So it says on question number 20, a radioactive substance has a half-life of 32 years. Find the constant K in the decay formula for the substance. So, I believe I don't have the formula with me, so I have to create my own formula. The formula is going to be A is equal to P times e to the R times T, or you can say A is equal to P times e to the K times T, where this is your final amount. This is your starting amount. Your K is your coefficient that you're looking for. And T is your time, and usually years. It could be in seconds or years. They actually tell you, nope, yeah, it's in years right there. So 32 years. So, a radioactive has a half-life. So this is a half-life situation. So A is equal to P times e to the K times T. Your T value is going to be, of course, 32 years. And you start out off with A. What is the half-life means you have half of that left. So if you started with P, then you have half of P left, right? So 1/2 times P is equal to P times e to the 32. I'm going to substitute that in there. So it's going to be 32 times K. There it is right there. The first thing we're going to have to do when we solve for K, it's in the exponent part, right? You have to get rid of that P. And since P is being multiplied by this, you divide it by P to the left side and to the right side. That gets rid of that. That gets rid of that. And that becomes 1/2 is equal to e to the 32k. You notice that the variable is at the exponent. You have to get it out somehow. And the only way to do that is change it into logarithmic state. More naturally, the natural log, because it's base e. So log base e, which is natural log, of 1/2 is equal to the exponent 32k. And that's how I do it. Log base e of this becomes the number. The exponent goes to the other side of the equation. Don't forget to go from exponential to logarithmic. You should be very familiar with these two concepts. Solving for k, since 32 is being multiplied by k, to get rid of that 32, I divide it by 32 right there. So k is equal to, let me bring this out, natural log of 1/2 divided by 32. That is your calculator ready form. Okay. I actually did this on the calculator, and it came out to be approximately negative 0.0217. Okay. Okay. So the second question. The population of rabbits in an area is modeled by the growth equation. PT, population as a function of time, is equal to 8 times e to the 0.26 times t, where p is in thousands and t is in years. How long will it take for the population to reach 25,000? So this value, since it's in thousands, is going to be 25. Everything's in thousands. So we just plug in 25 in here. You're looking for the value of time t equals, right? How long will it take? So plug into the equation, you get 25 is equal to 8 times e to the 0.26t. To isolate this factor right over here, you have to get rid of the 8. How do you get rid of that 8? We divide it by 8 right there. That gets rid of that right there. So we have e to the 0.26t is equal to 25 over 8. This is an in exponential state, we have to change it to logarithmic state. So the natural log, which is base e of 25 over 8, is equal to the exponent goes to the other side of the equation, 0.26t. To solve for t, how to get rid of the 0.26? Since it's being multiplied right here, we divide it by 0.26. So finally, t is equal to natural log of 25 over 8 divided by 0.26. This is in calculator ready form. I actually did that calculation for you. Let me look it up really quickly. Natural log of 25 over 8. I can put parentheses around that. Divide by, that should be approximately 4.4 years. This is what's called a instantaneous growth rate or decay. Okay, you can use it for a half-life as well. There is an alternate formula for the half-life. You can use like A equals P, the amount times. So let me write this down. Let me see if I can do it from memory. A is equal to P times half of T over the half-life, whatever that half-life was. But there's no constant K, which is what you're trying to find in this equation. So it's a little bit different than this equation right over here. Think of PERT, P-E-R-T, as it used to be a long time ago, before you guys were born. It used to be a shampoo. Anyways, good luck on your test or your homework.